Hello, welcome, and I want to show you today a little bit about monitors and how they can be used, because they are still floating around a lot of these old CRT style monitors which were used for the Commodore 64, the Amiga and other consoles. And usually you would pair them up with the C64 or something like that. And yeah, a lot of them are ailing and going bad, but there are still people repairing them. This one is actually in pretty good condition. This one is a Philips CM8833-II. And it was a typical monitor that you would buy with your Commodore 64 or maybe the Amiga 500 or something like that. It has roughly TV resolution. It also supports scan rates in the TV range 50 to 60 Hertz. So it is rather grainy. It has not as high resolution as a VGA monitor, for example. But it has one interesting side effect. It has quite a bunch of inputs that we will take a look at shortly. And especially it also has an RGB style input that can be switched to TTL. And TTL is the same standard, which is basically digital RGB, red, green, blue data, that was used with the IBM CGA and EGA cards. The VGA standard switched to an analog input and a higher scan rate than this would support, but the CGA 320x200 or 640x200 line modes are actually compatible with the TV-like construction of this device. You could perhaps also use something like a regular TV with a composite output on the CGA card, but normal TVs back in the day wouldn't have a TTL level input, so that would not work. So let's take a look at the back, and then afterwards we will hook this up to a CGA and EGA card and check out what the display would look like. The problem being that original EGA and CGA monitors are harder to come by, I would say. There's still a lot of VGA style CRT monitors floating around there which will not support the EGA cards. So it's very hard to get old CGA and EGA cards running with real monitors from the era. Here, at least in Germany. In the US, I think there are more of those CGA style monitors floating around. So you can actually use this kind of monitor to power a lot of different devices. You can also hook up the Amiga, as I said, or something like the Mega Drive. I've used that on here as well because this thing here also supports RGB analog input, which is fine for the Mega Drive. Or just composite cable, which is what I'm using here with the Commodore 64 actually, and it is a pretty sharp picture even with that. Okay, but let's turn this thing around, let's have a look where to attach things and also which caveats there are for things like EGA cards. So this is the backside of this rather old monitor, and it has the usual stuff. There's the power button, which is also prone to fail. But it can be bridged basically, leaving it always on, and then you use like a power strip to turn it on and off if you can't get a replacement for that, because those are usually not manufactured anymore. A standard IC, I think it's called power socket, a knob for the horizontal size, vertical size and vertical shift. The horizontal shift can be adjusted from the front of the screen basically. Then we have the connectors here, which is a DB9 or D9 9-pin, just as usual as you would see on many of those monitors and also on CGA and EGA cards. And then you also have these RCA style connectors. And one thing to note are the two push buttons here. When the right button is not on, basically now it's in the off position, we have an RGB signal, so this input is selected, and then you can choose between TTL and analog by pushing the button in. So currently it stands at RGB and TTL, which is suitable for CGA and EGA cards. EGA with an asterisk. EGA cards will only run in 200 line modes. The special high-res modes like 640 by 350 and enhanced colors, 16 out of 64, will not be usable on this monitor because the signal will be too high basically in the refresh rate. This only supports something around 15 kilohertz or something, and EGA has way higher resolution, of course, in 350 and requires higher refresh rates. Anyway, if we switch this one to CVBS, this will enable the composite input. Yellow is the composite here. And in theory, this should also support a third push button to switch between CVBS and LCA. CVBS being the normal composite input and LCA being separate, Loom and Chroma. I guess it is possible, if you were to open this up, to install the push button here and also install a fourth connector here for the Chroma. So you would have Luma here and Chroma there for a separate signal, which gives an even sharper image, which could be used on the C64 or the C128 or something like that. But that is not the case, as you might guess. Right away from this, you would have to drill a hole and put the push button in there and another RCA jack. So there were variants of this monitor which supported that. But I think the picture, even with composite, is actually pretty neat. So yeah, I think that's fine as it is. But we will leave this at RGB and TTL and we'll have a look at what quality we can get out of a CGA and EGA card. And what games used to look like back in the 1980s, basically, without having to resort to emulation and TFTs, which is also fine by me, but seeing old hardware run old games on period correct monitors is also pretty nice, because at some point in the future this will all be gone, because these things wear down and will break, and there are no more CRTs being made, at least right now. Who knows if there will be a comeback like with vinyl records or something, but I doubt it, because let's face it, CRTs are nice in a way, but the LCDs that we have nowadays are definitely much less power hungry, much less heavy, and the shaders emulating the CRTs are getting better every day. So I doubt that anyone will ever make something like this again, but it's still nice to be able to see how this all used to work 30 to 40 years in the past. So let's have a look. I do have two EGA cards here. One is this ATI Wonder E800 Plus, which is a pretty late EGA card. And this one seems to be coming from a Commodore PC-30, I guess. And as you can see, this EGA card has space for a VGA output. I'm not sure if it would be using a RAM deck, which could be fitted here, or if it has any VGA compatibility, or if it's just only an EGA card with basically optional VGA output. But mine here only has RGB TTL output. However, here are the crystals, and none of these have the regular, I think, 16.257 megahertz, which is common for EGA output. So even in standard modes like 320 by 200 or 640 by 200, it will not output a standard EGA signal. So it would have been paired with a multi-sync RGB monitor of a different variety, which doesn't matter too much for me in general, because I can plug it into the RGB to HDMI, which I have shown in a previous video. But for today, it is actually not an option, because we want to hook it up to the Philips CM8833, which is a regular 15 kilohertz monitor suitable for basically TV-like signals like the C64, Amiga, Genesis or whatever, and also CGA incompatible. So this one won't be shown today. But what I also have is this also relatively late Paradise EGA card, which probably also has some display modes which exceed the regular EGA ones, but I'm not quite sure. I will just drive it with the regular EGA solutions, and here you can see we have the 16.257 MHz crystal, so it will drive a regular CGA monitor with that. And another point is that you also have the dip switch block, which is common to EGA cards, where you can configure which display is attached, because the card usually doesn't know if it's attached to a high-res EGA monitor, which can do 640 by 350, or to an older CGA monitor, which first of all can only do 16 colors instead of the palette of 64, but also cannot do the 640 by 350 resolution. And as you can see here, right now this dip switch block is set so that only bits 2 and 3 are set to on. And if you want to drive this on a CGA card, you have to turn these off, on a CGA monitor, sorry, and turn switch 4 on. Usually you only have 4 switches. This one also has a 5th switch, which is, I think, for auto sensing capability or something, if the monitor probably supports it. I'm not going to touch this here, but the first 4 switches are the same on all EGA cards. I forgot what the first one is for, maybe even for mono mode or something, but using this switch setting we should be fine to drive the Philips CM with this card. This is already a relatively well integrated card. You have most of the custom logic collected into these 2 big chips, and it also has 256K of RAM, which is the maximum amount that EGA usually supports. And as you can see, it's from early 1989, as it seems. At least the date code here suggests that. So by this time VGA was already available, but most probably people were still buying these because they might have been a little bit cheaper than VGA cards, and especially you would have been able to reuse your old CGA monitors with this switch setting and still be able to play relatively modern games around 1989, 1990, and maybe even up to the early 1990s. So this is what it looks like when MS-DOS has booted up on my 486, sporting the Paradise EGA card and connected to the Philips CM8833-II. Well, this is a CGA monitor technically, and you can also connect analog sources like the Amiga or composite sources like the C64 or other consoles or home computers. So this is not truly an EGA monitor, as I said, but the EGA card was always supposed to be backwards compatible to the CGA with some caveats. We can only run 200 line mode resolutions, that is 320 by 200 or 640 by 200, and this is here the 80 color mode, which is a text mode running at 640 by 200. And when we start QBasic, for example, I have written a little test program to show that, for example, we can also output into 40 color mode with all the 16 colors available on the CGA card in text mode or on the EGA card as well in graphics mode, and this is actually graphics mode. And we also see that this monitor correctly displays the brown color, which is here the, I think, 6th line, because technically it should have been a darker yellow, but IBM tweaked that and made it a brown. So it seems like this monitor was actually designed to be run with CGA or EGA cards. If I were to run a high-res EGA program, like for example Windows or any of the adventure games by Legend Entertainment, we would have a little bit of a problem, because we would get wheezing noises and all messed up screen, and I'm not sure if this monitor would like that, so we better not do that. The text is pretty sharp, I must say. Let's start the DOS controller here. It looks really nice. Of course, it's a little bit less readable than on a true EGA screen, because you definitely have less pixels here. Let us run a couple of games and see how they look. And the first game we're looking at is Monkey Island 2, and it actually supports EGA graphics cards, but not in a way that most people would assume. Usually the games back in the day would be 320 by 200 in 16 colors, but as you can see, this looks like higher resolution color space, so to say, because there are colors visible here that are not on the CGA card. And the fact is, this game is actually running in 640 by 200, and it uses clever dithering to down-convert the VGA palette that the game uses into the 16 colors we have on the CGA card. This is of course not possible on a regular CGA card, but only on EGA cards, and yeah, it actually works pretty well. The game came out in 1991, and there were probably still a lot of people running 286s or maybe even Turbo XTs with EGA cards, and I'm not sure that it runs on an XT. I think it requires a 286, but something like a NEC V20 would be perfectly fine running this, probably very slowly. So people would be able to still play the game, maybe see that it's cool and upgrade their hardware later. But I think this is an excellent example of how late to the game EGA cards could still be useful for people running older hardware and playing relatively modern games. The same applies actually to Indiana Jones and the Fate of Atlantis, also known as Indiana Jones 4. And it even emulates, as you can see here, the fade-in and fade-out effects of the VGA card, albeit it's very slow because it has to redraw the whole screen using dithering. And the question that I ask myself is, why did they bother doing that? Because it's yeah, super slow. Instead, here, like, the zoom in of the Indiana Jones logo is super fast. But Indiana Jones and the Fate of Atlantis actually uses the VGA palette in quite a few number of rooms, where you enter a room and it's pitch black, and the longer you stay, the brighter it gets, because Indy's eyes adapt to the darkness. And so they had to actually make this work somehow on the EGA card, and that works by actually doing the palette emulation fully. And they skipped on that in Monkey Island 2 because it doesn't have any such rooms where it's so important. So that's, I think, a pretty neat detail of the way that Indiana Jones does that. And I think this was actually the last game by LucasArts to support the EGA card. I think this came out in 1992, and by then VGA truly had taken over and people were upgrading left and right, and EGA and CGA were just very, very obsolete by then. One game that was truly from the height of the EGA era was, of course, Loom. It came out right before or around the time that Monkey Island 1 came out, so in 1989 or 1990. And yeah, it was one example that is always cited of having very beautiful EGA graphics and utilizing the EGA card in its low-res mode to its fullest extent. And I must say, yeah, it definitely looks very nice on this CRT. It's hard to capture, so you see some blooming and the blacks don't look as good as they do in person. But I think EGA and Loom really fit together. So back in the day, you would probably have this game because it would perfectly run on a Turbo XT or something. Original XT would still be a little bit too slow, I would guess, at least in the scrolling portions when Bobbin is walking through the rooms, etc. But I think this works actually pretty nicely, and the relative blurriness of the CRT makes a very nice visual appearance, especially considering when the graphics use heavy dithering, as you can see here, to produce different shades of colors. So I think this is a great example of EGA at its prime. PCs were never very good at doing platform or smooth scrolling games. However, back in 1990 or something like that, a company called id Software, which would become very famous with Doom and Quake, came out with something called Commander Keen, and they utilized a lot of tricks that the EGA card introduced and the VGA still supported. And this led them to write an engine that actually supported four-way scrolling on a PC, which wasn't ever meant to do really that. And this is something very, very, very built into like consoles since the times of like the NES or the Master System. So Commander Keen actually runs pretty nicely on such a monitor. My EGA cards here have slight compatibility issues, not especially with this version, Commander Keen 1, but later versions did some more clever tricks. And as you can see, there's quite a bit of jittering happening here, which isn't supposed to happen, and on certain Super VGA cards it even happens, and there's an option in Commander Keen Goodbye Galaxy to configure that. But it doesn't help on my EGA card, so I researched actually a little bit, and there are patches for the binaries to make the scrolling better. It's basically some timing and hardware options. But still, Commander Keen on a EGA card and a CGA style monitor or C64 style monitor with TTL input works reasonably well, and you could basically have a nice jump and run experience similar to what you would get on the NES or Super NES with less colors obviously. And yeah, I think id Software did something very great here and achieved something that no one ever thought would be possible on a regular PC without all the hardware for sprites and scrolling. And id Software and Apogee also brought out some other games, something like Wolfenstein 3D, but that did run only on VGA cards. But there was a game before that, and that game was called Viccatacomb Abyss 3D. And that was actually a first-person shooter running on EGA graphics cards, and as you can see here, it runs absolutely fine. The frame rate is pretty limited, but I think that is due to the fact that the engine doesn't support anymore. I think the EGA card could perhaps push more pixels than what you're seeing here, and the 486 especially, it probably is idling quite a lot in between frames. But yeah, amazing to see that you could have a first-person shooter with textured walls back in 1992 on an EGA card, and probably a 286 or something with, yeah, quite good success. All in all, I must say that some of the games utilized the EGA card to very, very great gains, like Monkey Island 2 here, for example, which definitely doesn't look like the usual 16 colors. And you could do away with some C64 style monitor if you got that, because they were relatively affordable and you can run all the CGA and EGA games up until something like early 1992 perhaps. After that, you probably would get some shareware titles which would still support this stuff, but the commercial games went away from EGA definitely in 1992. But I think that's it for today. Thank you for watching, and if you have a monitor like this at home, make sure to try it out with your CGA or EGA card, if you can get hold of one, that is, of course, because I think it's a real nice thing to experience the games on this hardware as long as we can, actually. And yeah, thank you for watching again. Please share, like and subscribe as usual. Leave a comment if you have one of these monitors or a true CGA or EGA monitor that can even do high res, or what were your original monitors that you used back in the day. And yeah, thank you again. And you can support me on Patreon, Ko-Fi or PayPal or even YouTube. Check the links out in the video description. It will greatly help me out in producing stuff like this. So long and see you soon.